Right, so here's what's going to be your homework tomorrow. Right, now the first one is a surd, so you want to simplify it. So again, to do that, you think of two numbers that you multiply together and try and find one of the numbers that you can actually take a square root that gives you a whole number. What if it's trial and error? So if we think what two numbers, we can multiply 1 times 98. You can't take a square root of either of these numbers, so it would end up being like this. They're not going to give you a whole number, so if we take, what about 2 times, well, it's 2 times 49, and it is just practice because you hopefully remember that, well, 49, you can take the square root of 49, right, so we can take square root of 49, should give you 7. So that then can simplify to 2 times 7, and we know another way of writing that is 7 root 2. Okay, now to simplify this, we're using the laws of indices, so if you think about the y to the power of 4 times y to the power of 5, what you do with these two is you add them together, so that's equivalent to saying y to the power of 9. Okay, and if we look here, so that's y to the power of 9 over y squared. Now, we know if we go y to the power of 9 over y squared, don't know why I'm writing that way there, it's actually, that's equivalent to saying y9 minus y2, which equals y7. So that is why the answer there is y to the power of 7. So if you're multiplying them, you end up adding them, and if you're dividing them, you're subtracting them. Okay? And we're talking about subtracting the indices, right? So 9 minus 2 and 4 plus 5. And with this one, what we do here, remember, you always look at if there's any coefficients, you multiply them together first. So that's 3 times 5, which is 15. Okay, now what we've got is if we are looking at the x, 3 times x to the minus half, we know that we have to add them together, so what we need to do is get them looking the same. So if we're doing this in halves, 3, if it was in halves, is 6 over 2. Okay, so that's equivalent to saying 6 over 2, because that can simplify to 3. So that's equivalent to writing it out this way. So what you've then got is we can then say you're adding these together, so 6 over 2 minus a half, which is 5 over 2. So that is x, that's 5 over 2. So that's another answer there, and well, essentially that's it simplified there. Okay, so with that, you want to get them in the same format, so you then think about essentially how many halves make up 3. So there's 6 lots of halves make up 3 wholes altogether. We then have a wee look here, and what we've got is we're saying that you have 1 light year is 9.46 times 10 to the power of 12. You times that, so just times that. Here what you have is 9.46 times 10 to the power of 12. Then we times that by 15. And what we get here is we've got 1 point, hopefully you can see with the light, 1.419 times 10 to the power of 14. Okay, so that equals 1.419 times 10 to the power of 14. Remember, you can use your calculator with this as well. Now, these ones are pretty simple, so what you want to do is you're essentially multiplying everything in the bracket with what's outside the bracket. So z times 4z is 4z squared, z times t is tz or zt, and you want to remember there's a minus here, so tz. This one here is we multiply the first element, so y times y is y squared. We're then going to look at y times 9, which is plus 9y. Then going to look at x times y, so that's plus 6y. And then I'm going to look at 6 times 9. okay, and that's plus 54. You'll always find that there's going to be 4 terms here, okay, and then obviously you collect them together, but there's 2 terms in this bracket, there's 2 terms, so they're going to end up with 4 terms. So we tidy this up, that's plus 15y plus 54. Sometimes you do it as FOIL, so FOIL, remember, is the first terms of each bracket, the outer terms of each bracket, the inner terms of each bracket, and then the last terms. This one here, we're just basically looking at what's in common. So both have a b, so we'll take b out of the bracket, and we think like b times what is b squared? Well, b times b gives you b squared, minus b times what gives you 8b, so b times 8 gives you 8b. Okay, so that's the first 3 page done for you. If we look at the second one, now the wee tip here is if you look at, and there's a number in which you can take the square root of, and it gives you a whole number, and we've already seen from the first question that you can take the square root of 49 gives you 7. What we do, 2 sets of brackets, put a c there, put a c there, put a 7 there, and put a 7, put a plus there, and a minus there. That will do that, so see it was c squared minus 36, or c squared minus 16. Now it has to be a minus, because what we can do is, if we double check this, multiply them, that gives you c squared, that times that gives you minus 7c, that times that gives you plus 7c, and then that times that gives you plus 40, minus, a minus times a positive is a minus, and these cancel out, so that's u back to c minus 49. I multiplied that out a wee bit daft, in terms of not as neat as the last time. Okay, then what we do is, with this one, we're looking at 2 sets of brackets, got an f here, got an f. We now need to think of 2 numbers that you multiply together gives you 18, but also that with these 2 numbers you can somehow work out 11. Okay, so think of maybe 2 numbers that give you 18, but if you multiply them together, if you add them or subtract one from another, it gives you 11. So I'm thinking, well, 9 and a 2, multiply them, it gives you 18, but you can also then say, well, if you add them together, it gives you 11. So remember, that would be f squared, that's your 18, that's your 9f plus 2f gives you your 11f. So it's always good, if you've got time obviously, but you probably will do, to then just multiply it back just to make sure it gives you that. Complete the square, so what we've got here is we look at x squared, we then look at this, and basically half it. Okay, so that's plus 3. We then look at this and basically square it, and we have to subtract that because we've just added a random, well, it's not random, but we've just added a 3, and it's going to eventually be squared, so we need to get rid of that, and then obviously we've still got that plus 10 here. So what that then does is it tidies up to your final answer is x plus 3 close bracket squared plus 1. So that's your final answer there. And I've not given myself much room for this. So what we do is we go 4x minus 1 x plus 3, and then we say, oh, that means, x squared, if you just saw x squared, you know that's the same as saying x times x, so x plus 3 bracketed and squared, that's the same, so x plus 3 times x plus 3. And what we can now do is we see if any of these cancel out, so that cancels out with that one. So that gives you 4x minus 1 over x plus 3. Okay, now, good old fractions. Right, so, I wonder if I should get another pen. Right, what we do, see with this, multiply that with that, and multiply that. And it's pretty hard to see actually, so we end up going multiplying 5 and a c gives you 5c. 3 in a b plus 3b. And we want them to have the same denominator, so b times c, because one's got b, one's got c, so multiply them together. And that's you with that. And it's the exact same principle. If you're subtracting them, multiply that, multiply that, multiply that. So 8w minus 4z over zw. This one's even easier, just multiply these and multiply these. So we've got 3nm over 5p. This one's a wee bit different. I'll take that, I'll put that over here. It's t divided by 6. We actually turn it into a multiplication. We go times, and we just flip this round, so change the numerator and denominator, and then you're just back to this method. You times that, and then times that. So that's t times g over 6t. You'll only be asked to do it 4 different ways, and that's how you do. So that's you're multiplying across, diagonally, and then horizontally. Same with that. So that method and that method are the same. This one's just multiplying right across, and then this one you flip it so it becomes multiplication, so you have to just flip these round. Okay, so what we've got here is calculate the gradient. So what we do is we say, well, we'll call this x1, y1, x2, y2. We know that m, running out of space, m equals y2 minus y1 over x2 minus x1. So what we've got is we've got 3 minus 2. Divide that, and that is, where's my x2, that's 6 minus 4. More often than not, you'll get a whole number as your gradient. That's equivalent to 5 over 10, and there's me saying a whole number, and this is a half. Right, there you go, so that's a half. Right, calculate the volume of this to two significant numbers. Right, so what we do is we just rattle all this into this equation. 4 over 3 pi, and then we've got 3 times 2 squared. You then will have a calculator. So let's get this. 4, right, in fact I'm just going to say pi times 3.2 squared times 4 over 3, and then press equal. Now, two significant figures is the 4 and the 2. However, you have to look at the third one to see if you have to round the second one up or down, okay? Or you don't round it down, you just keep it the same, right? So obviously we're going to have to round this up, because it's right now it's 4.289 blah blah blah. We look at this one, that's going to actually put this up to 43, so there's 43, and it's centimetre, remember, volumes cubed. And I probably shouldn't have drawn on the screen. Right, so, and then we're nearly there. Hopefully that's, the fraction's correct there. Yep. Right. Then we want to work out SD as a minor arc, and we basically want to work out what's the length AB. Calculate the length of minor arc AB, which isn't actually mentioned anywhere. I think that's probably, that should say ST. Because that's your minor arc there. It's not really done much use actually. So that's your minor arc. So what we have is we basically say arc length equals, take the angle in the sector, 155, divide that by 360, and then times, remember, calculate the perimeter, it's pi d, right, because we're just calculating a fraction of that, so it's basically pi d. We know that's your radius, so therefore diameter is, remember, that's 2r, right? So what you're wanting to now do is we're now wanting to just 155 divided by 360 times pi, that's 36, so that's times, just put 36 there, it's not the neatest in the world. So what we do is 133, probably when you actually see the calculator, divide by 360, times that by pi, times by 36, and that's the size of it, 48.7 we'll say. So that's 48.7, I'm just going to double check that, because I know it might not be this, it will be the scale, right? So we'll just want to double check, so that was 155, divide that by 360. Then I'm going to times that by pi, then times that by 36, and do get the same answer. Okay, and that'll be centimetres. Now what they're asking is Stephen wants to put tinsel around the base of the hats. He's 100 metres of tinsel in stock. What's the maximum number of hats that you can do for 100 metres? Now this hat itself, so it's basically that, plus that, plus that. Okay? So what we need to do is we need to add 48.7, which we've calculated. Have to add 18 for this part, and then plus 18 for this part. Add that together, so I'm just going to say plus 18 plus 18. 84. Right, so that's 84.69 centimetres, so that's how much you can get for one. Okay, so that's equivalent of, why don't we then think, so there's 100 metres to play with, right? Each one is obviously less than a metre, right? So we need to work out what do we want to turn this into metres or turn this into centimetres. I'm just going to say, if we go 100 metres and then divide that by, we'll just say 0.8469 centimetres for each one. We can then work out how many hats we've got, right? So we can say 100 metres divided by 0.8469. So we've got, now we're not going to do 0.07 of a hat, so that means 118.07, so therefore it's going to just be 118 hats. Okay, is max amount. So it does tell us your final answer, and then obviously that's showing you you're actually rounding it down, because again there's a wee bit of tinsel left over, but it's not enough to make a hat. Right, so these are quite common questions. And that takes us to the last one. Right, chemist flasks, and we've got one that's got a radius here, and then it's put into a beaker here, and they're just asking you, is the beaker going to overflow? So what we've got here is this one, it's the radius and the height, so I'll just write it down here. Right, that's your wee cone, and then that's basically a third pi, radius is 7 squared times 9, which is going to equal to, right, pi times 7 squared times 9, divide by 3, 461.81 centimetres cubed. We've got a cylinder, so the cylinder, got a wee cylinder here, and that is a now that's not right. The cylinder is obviously, that's pi r squared, and that's the height. So the volume of the cylinder is pi r squared h. So that's going to be pi r squared h, which is going to be pi, says the radius here is 3, so that's pi times 3 squared times h, which is 8, which equals times 3 squared times h, which is 8, 226.19 centimeters cubed. The beaker will not overflow. Just want to double check that, and probably my video is probably too large to upload now. Right, so pi, so that's times 3 squared times 8. I mean, there's quite a difference, so there might be a wee. So considering there's a wee error here, there might be an error somewhere else in this question. Right, but certainly, if it's a normal cylinder, it's the area of the face just times the height. And hopefully that's helped you with your homework. Shame about the last wee question.